Hey folks, this is the first part of lesson 5.2. Today we're going to focus on amplitude, period, and thinking about where the midline of our trig functions are, at least for sine and cosine. And we're only going to graph sine and cosine today. So I just want to play around with the idea of sine as a function and thinking about various things. I wanted to point this out to you. This is Desmos graphing and it's online. And so it's desmos.com. And in the book, they suggest that you can use the new plot and they have an appendix. But I think that this is just as easy and the graphs turn out just as nice. So I'm going to give you a quick lesson on this. So that's sine of x, right? We're familiar with that. Sine of, now I want to do sine of 2x to explore that. And I think you can even change the color of this. But we'll just keep going with that. And I want to focus, so if you actually use your cursor, you can scroll in. So the sine of 2x, and then the other thing that you can do is you can list points. So this is the sine of 2x, if you and I know that because basically the sine of x, which is the graph that seems more stretched out, I know that it completes one full cycle at 2 pi. And so I can just look and observe that. Whereas the sine of 2x, it's interesting. It seems to complete one full cycle where it returns back and it goes up and then it goes down. So it returns to pi. So the period of sine of 2x is pi and the period of sine x is 2 pi. If we graph, for instance, sine, now I'm going to do 1/2 of x. So that actually seems to stretch the graph out horizontally, whereas sine of 2x shrinks the graph. Now this is something that with transformations that you'll see in pre-calculus, but this number in here, if sine of 1 if it's between 0 and 1, it's actually called a horizontal stretch, and if the number is greater than 1, it's called it's a horizontal, it shrinks the graph horizontally. That's not something that you have to memorize, and I'm going to show you how to find the period. In this case, with the orange graph, if I have to zoom out to actually figure out when it goes back and completes one full rotation. I'm saying rotation because how long does it take it to go through all of the motions before it starts to repeat and do the same thing? See how we move it along. If I move this graph, sine of 1/2 x, the period, see it starts and then it repeats and does the same thing again as I'm moving. And it goes back to this. So every 4 pi, the graph repeats, and that's why that's the period. So if you use Desmos Graph, one way to create this image, if you wanted to put it into a document and turn it in for homework, you can do the print screen and then you can copy it and then open a Word document and paste, crop. And so this is how I get images into the drawing program that I use. I do want you to be able to use, so I just cropped it and hit enter, to be able to graph some of these by hand, but this is just like if you have a really complicated graph, you could use that program and have a nice graph like lined out for you. And if you ever get stuck with any of these, go to your graphing calculator or use the online, the Desmos, and use it to your advantage. And then it can help reaffirm, that you found the correct period and the correct amplitude. So since we're on it, and we'll talk about amplitude now, and we'll talk about period in a little bit, I want to go back to the sine of x. So here's the sine of x. I know that it has completes one full period in 2 pi radians. Now what happens if I put a 3 in front of sine of x? Well, you can see, it looks like it's getting stretched out. And I know some of you have had experience with different functions and what the transformations do. So what do you think will happen if I do 1 divided by 3 sine of x? Well, it does basically, it takes your sine graph, all of your outputs, and it does a third of it. So see how this value right here, 0.333, this value up here on this graph is pi over 2, 1. So basically, every output I have, I take a third of that output. So let's just do, oh, and then here, since we're up here, pi over 2 and 3. So this 1 gets multiplied by a factor of 3, okay? So everything gets stretched out with the 3 in front, a number that's greater than 1. And now we're talking about a vertical stretch, and everything that's between 0 and 1 gets squished, okay? So let's just look at, I'm going to erase this, and now I'm going to do negative 3 sine of x. And what's your prediction? Well, it's the same graph as the blue up here, only it's flipped. And this negative flips everything about the x-axis. So this is a flip about the x-axis, a rotation. Okay? So if you have a negative, instead of going up first, you're going to go down first. Okay? So it's really important, I can't emphasize enough how important it is to understand what sine of x, the basic sine graph and the basic cosine graph, is, and like some of the values. And like I said, the most important values, 0, 0 for sine, pi over 2, 1, pi 0, 2 pi, and then here's this one down here. And of course, remember the pi over 4. So I think if I linger enough, it'll show me where halfway. Doesn't look like it's going to find it for me. I was trying to get halfway between pi over 2 and pi, and it's not going to do it. It's not going to just show me. That's too bad. But you got the idea of the different values. So it does show you the main guys. And thinking about now the amplitude. So in the book it shows this picture and it shows the distance from, basically, I like to call this the midline. And I don't even think the book ever mentions the midline because everything is centered around the x-axis here. So the distance from here up to the very top up here is 3 units. And that's the maximum that this function 3 sine x and negative 3 sine x can get. So that is what's known as the amplitude. The amplitude has to do with the number that's out front, and it's the absolute value of the number. So this negative doesn't really factor into the amplitude because even with that negative, I'm still going down, as you can see here, 3 units. That's the farthest away from that midline I'm getting. And same here with this midline. That's the farthest away from the midline I'm getting. Okay, so to find the period, it's in this formula of this form. So if you have a function of the form f of x, and I'm going to use function notation because I think it's important, sine of omega x. A lot of times another alternative form, and in the book I used to teach in, it was sine of a, no, actually this was b. They used bx. Okay, so you may see that in other books, but they're using the Greek letter omega. So the period of this is going to be 2 pi over omega. You can see the proof in the book, but for now I'm just going to give you the formula, and this is something that you should just memorize and know, that it's 2 pi over the coefficient of whatever's inside, the coefficient of this angle x, okay? So whatever's in front of the x, you take that coefficient and you put it underneath in the denominator and 2 pi. So for instance, if I gave you that, and we can calculate the ones that we did, the sine of 2x, well, to find the period of that, we can say that that's 2 pi over 2, cancel the 2's, and so that means that the period is pi, and that does confirm what we saw on the Desmos graph. Now if I did another function, f of x, and it was the sine of 1/2 x, well, that's 2 pi over omega. This is your coefficient of x, that's 1/2. If you flip it, it becomes 4 pi. So the graph completes its full cycle after 4 pi radians, and in this graph, the graph completes the cycle in just pi radians. Another way to think about this 2 will speed things up, and this 1/2 is going to slow things down, so it takes a lot longer for it to complete its full cycle. And this is the idea of amplitude of a function. You take the maximum of it. So we had something like it went up to 3. For our graph, it was 3 sine of x. That was f of x. So the maximum it got was 3. And then the minimum it got was down to -3, and you divide it by 2, and that is equal to the amplitude. So amplitude will be 3 plus 3 over 2, which is equal to 6 over 2, which is equal to 3. Now this seems obvious in when you're doing it like this, and the midline is this line. And this line right here, the x-axis, is y equals 0. So I want you to kind of think about the idea of a midline, where the focus is. So it's basically amplitude. The maximum it can get is 3 units if we looked at that example from the midline. Or we could say A units. So absolute value of A, it's A units from the midline. Putting it all together, we've got these two functions here. If basically sine takes on this form, and we're actually going to skip phi for right now. We're just going to look at the form like this, a sine, and we'll do this in the next lesson, omega x, and I'm going to call it f of x. It's a function, and then our other function, f of x, is equal to a cosine of omega x. Okay, I'm going to ignore this. This right here will factor into the phase shift, and just so you know, the phase shift just moves things to the left or to the right, where you start from. Okay, but right now I think it's important that you focus on just these two forms of sine and cosine. We'll talk about tangent and we'll practice tangent. As far as cosecant, secant, and cotangent, I want you to be able to find it using the formulas, which I will provide for you for these. But basically, you can always use a graph for graphing these, and that's what I want you guys to do for that assignment in 5.2b. I don't mind if you use the graph, and it even says that in the directions that you can use new plot, but you can also use Desmos graphing. Okay, so we're going to graph -2 cosine of 2 pi x and -2 cosine of 2 pi x plus 1. All I want to say is that this plus 1, and sometimes it's a plus k, can be thought of as your midline, because this basically will shift the graph up or down, and we've talked about that a little bit. So the -2, and we're going to look at this formula right here, we can see that the amplitude is the coefficient of the cosine or the trig function. It's the absolute value. So the absolute value of A in this case is the absolute value of -2. So we can say that the amplitude is 2. Okay, so that's the amplitude. Notice that that does not change this at all over here. The amplitude is 2 for both of these. To find the period, we know that the period is 2 pi over omega. Well, omega in this case is equal to 2 pi. So we have 2 pi over 2 pi. And it's kind of nice when you get rid of your pi, because then that means that you can do a scale. Your period is 1 unit. You don't have radians on the x-axis anymore. You're just dealing with 1, 2, 3, 4, and such. So the cool thing about that, and also I'm going to be specific on what I want you to graph. So I would say graph this function between, maybe we'd say, let's just do -1 to 2. So if I graph this, I'm going to draw my x-axis here. Not a very straight line. It's hard to draw on this tablet. And I'm going to go here. And let me get a darker color. So then I would say, okay, I know that I complete one full period in 1 unit. Okay, so I think that it's important. let's see, if we complete one full period in 1 unit, let's see, with cosine, we've got 1, 2, 3, 4. I'm going to call this 1 unit. So this is a half a unit, this is then a fourth, and this is 3/4. So with cosine, usually the cosine graph, it starts basically up at 1. And so I'm going to say that this is 1. I'm going to scale this to 1 and this to -1 for now. So with cosine, I'm going to start here. But what does this negative tell me to do? Instead of starting up here, I actually have to start down below because the negative flips everything. So if I were to sketch the cosine graph, the original cosine graph, it would be up here. Okay, but we're not going to do that. We're going to undo that last drawing bit. And we're going to start down here. And because the period is 1, I'm going to end here. Notice I don't have a plus k. I'm graphing f right now. I don't have a plus anything out there or a minus, so it's not shifting it. I know that my midline for this one is 0, y equals 0. So I'm going to start here and end here. Well, cosine also, it finishes and it gets up to its maximum at the top. And so the very top, halfway in between these 2 points. So I can draw that dot. So that means that it's at a maximum at 1/2, or x equals 1/2. And then halfway in between, it's equal to 0. Between each of these, it crosses the x-axis. So I can draw my cosine graph like that. Okay, so I've completed one period here. And it doesn't look like it's a full rotation, but if you put these two edges together from here to here and here to here, you have completed a full cycle. So we want to go all the way up to 2. So we're going to go 1, 2, 3, 4, and here's 2. And once again, I've got to finish here. And halfway in between 1 and 2, I'm going to be at the maximum up at the top. Halfway in between 1 and basically that's if we do 3/4, 4/4, 5/4, 6/4, which is 1 and 2/4 or 1.5, right? So we've got this at the top, we're here. So that's just playing with fractions. And then we finish down here because we cross 0 and 0. And we need to go to -1 on the other side. So you finish, you know that the period is 1. So here's -1. That means I'm going to finish right here. Halfway between, I'm going to be at a maximum up here, and then I'm going to do the zeros. So here is my graph, like that. So I made a major boo-boo. I realized I scaled it, but the amplitude is 2, so you might be confused, wondering, wait, what is she doing with the 1 and the 1? So change that to a 2, because this is the maximum. You're going up 2 units from the midline, okay? So now we're going to graph g of x, and I'm going to use blue. And now this midline here, this tells me where that line y equals 1 is going to be. So the graph of g is going to be centered around this line y equals 1 because everything gets bumped up 1 unit. Okay? And then basically I'm going to start at the beginning. Cosine is usually it's above the midline, but since it's negative, it's below. And from here, it's 2 units below. So here I am. I'm 2 units below from the midline because that's the amplitude, right? A height of 2 units or a length of 2 units. I know that I also complete one full rotation right here, okay, at 1 because the period is 1. It doesn't change. And then I go up 1 unit halfway in between with my period. I know that I'm at the very top with the way that cosine is designed. Now I cross my midline halfway between that, halfway in between that. And so here, whoops, I didn't go up 2 units again. Okay, here we go. That looks better. 2 units from the midline, and then we're going to go down and cross there. Okay, and you can repeat this. You know, in 1 unit, you're going to be back to where you started. Halfway between, you're going to be 2 units above the midline. Halfway between that, you're going to be on the midline. And then you can graph that. And then same with this. In 1 unit, you're going to be back to where you started. Halfway in between that, you're going to be 2 units above the midline. And then halfway here, you're going to be here and here. So you can just draw the cosine graph. So I think this is enough to get you started. The worksheet isn't very long. Actually, there's one more thing I want to show you. Okay, so if we need to find an equation of this form, which I ask you on the worksheet that I'm giving you for this lesson, basically you have to use the graph in the information, and you need to find the amplitude from the graph, and you also need to find the period. Or actually, you already know the period from the graph, but you need to find omega. Okay, so we know from the graph, you can see that this distance right here, that maximum is 3 units, the maximum here is 3 units, and the maximum here looks like 3 units. Since they say that this is cosine, it matches cosine, meaning it completes one complete cycle in, it looks like 6 pi radians, okay? So we can say that the period in this case is 6 pi. Okay, so the period equals 6 pi, and we also already know that A is equal to 3. The only other thing when you're writing your equation, so we're close, we've got f of x is equal to 3 cosine. I don't know what omega is, but I know x, so we need to find omega. The only other thing too, if we had started down here, if the graph started down here, then it would be negative. Your function would be negative 3 cosine of whatever your omega is in x. And we can do that too. If it looked like the mirror opposite, right? Like that. Okay, because that flips everything to negative. So you have to look out for that. Because remember, amplitude is only absolute value. So the period is 6 pi. Well, what's the formula for a period? The formula for period is 2 pi over omega. Okay, so you need to solve for omega. And notice it's a nice thing. The pi's cancel out. I'm going to bring omega over to the top. So we have 6 omega equals 2. If I divide both sides by 6, I get that omega is equal to 1/3. So the last part of this is the 1/3. So my function is f of x is equal to 3 cosine 1/3 x. That should be enough for you guys to graph these. It might be nice to include a table of values, but please get this started and try to do this before you watch the next lesson. Let me know if you have questions.